Welcome to this section on CoppeliaSim, where we will going to design a Bubbleob robot using the CoppeliaSim. This lecture will be fully based on the creating the Bubbleob robot. So we will not go into the theory part of it. We will going to follow the steps on. So we will be using this CoppeliaSim software, that we are using the CoppeliaSim education version, and this version which we are using is the CoppeliaSim education version 4.3.0. okay. Now we have got a new version of a CoppeliaSim also available, so there are the few steps that will not going to be same as we will going to follow this tutorial. So this is the old version which we are using. So this is the scene object and we will going to create everything here. So there are the few steps which we have to follow. First, what we have to do is that we have to add a primitive shape of a diameter 0.2. So how I will going to add is that I will go on to the add button, and there I will going to select a primitive shape, and in this I will going to select the sphere, and then I will going to put 0.2 along the x-axis. So I will going to get a sphere of a diameter 0.2. So let me show you here that I will go on to the add primitive shape sphere, and here I will going to add 0.2 and click OK. So you can see I got a sphere. Now the next step what we have to do is that we have to double click on this teal color shape, and then we have to click on the show dynamic properties, and then we have to make this body as a respondable and body is dynamic. Clicking on this show dynamic property, by default it is been the body is respondable and body is dynamic. If it is not available, you have to make it. Then what we have to do, we have to again click on this, double click on this teal color shape, then we have to go on to the common, and we have to make the object to be a collidable, measurable and detectable. That means we want to make this body of a Bubbleob that it can have a collision, it can measure the collision, how the collision has been done, what is the distance, and it should be detectable. Okay. So I'm double clicking it, going to the common, and here you can see object special properties. I'm making it a collidable, detectable and measurable. Done. Now what we have to do is that we have to rename this sphere as a Bubbleob, and see that the R in a Bubbleob is capital. Okay, so how you will going to do is that you have to double click on it, you have to give the name Bubbleob, and you have to press enter. Okay, then only this name will going to change. We have to click here, we have to give a bubble R capital robe, and then we have to make a enter. So you can see now we have created a sphere with the name Bubbleob. Now step number 3, what we have to do is that we have to open the position dialog. In a translation tab, have to represent the Bubbleob as a body. Okay, and we want to enter it that it should be 0.02 along the z-axis. So basically what we are trying to is that we want to put that sphere little bit in the air. So it is around 2 centimeter above. How we will going to do it, that we will go on to the position dialog, and then we will click on the translation tab, and then we will going to select enter 0.2 along z-axis, and then we will going to click translate selection. So you can see that the Bubbleob will going to be shifted 2 centimeter along the absolute z-axis. So you can see here at the corner we have got z-axis, at the top y and z. So when we are shifting it upward, okay, that is means we are making a movement at the upward. Position tab, translation, along z we have to enter 0.02. Remember these things, okay, otherwise any step you are missing, it will going to lead to a wrong designing. And click translation tab. So you can see that the Bubbleob has been lifted little bit. You can also see it from here. If you rotate this, now you can see that now our Bubbleob is lifted upward. It is not touching the ground. The next step what we have to do is that we want to add the proximity sensor to the Bubbleob, so that it can be able to detect that which obstacle is approaching it. So basically in this we will going to add a proximity sensor of a cone type. Add proximity sensor cone type. So here you can see I got a proximity sensor like this. Now what we have to do is that we have to rotate this proximity sensor, okay, and it should be facing towards the bubble rope body in a center, and it should be inclined in the we can say it's act as a eyes. I want to create a eyes of a bubble rope, so we want that it should be facing towards, not upward, it should be facing like this horizontally. Whatever the proximity sensor which we have designed, we have to do the orientation, we have to rotate it. Okay, so we have to enter 90° around Y, and we have to enter 90° around Z, and then we will going to click on the rotation selection. Okay, so you have to click on the orientation selection. Okay, then you have to click on 90° on the beta. Beta means we are talking about the Y, and gamma means we are talking about the Z. And then we have to go to the rotation tab because we want to rotate it, and then we have to click on rotation selection. We will go on to the orientation tab, then we will click on orientation, then we will going to enter 90 along Y, that is beta, and 90 along Z, that is a gamma, and then I will click on rotate select. So now you can see proximity sensor which I am getting is under the ground. I want to lift this proximity sensor at the top so that it should be in the center of the bubble rope. To do is that we have to click on the position dialog, and then on a position tab we have to enter 0.1 along the X coordinate, 0.12 along the Z coordinate, and you will going to find that the proximity sensor which we are having will be in the center of the bubble rope. So we can say that proximity sensor is now correctly positioned relative to the bubble rope's body. We have to go on to the position tab, then we have to click on the position, and then we have to enter 0.1 along Z axis and 0.12 along Y axis. Okay, now can you see it is coming at the center of the bubble rope. Now next step what we have to do is that we have to rename this proximity sensor as a sensing nose. Okay, so we will going to do the same thing, that we will going to rename it as a sensing nose. So I'm putting it here, sensing NOSE. Again we have to keep the N capital. Okay, otherwise when you are running the script it will going to throw the error. Now what we have to do is that we will going to double click on this sensing nose icon, and then we will going to click on show volume parameter, and then we will going to adjust the offset to 0.005, angle to 30°, because we should not have wide area, it should have some narrow area. So we will going to minimize the angle, so we are putting the angle 30°, and then we are saying that range to the 0.15. Actually we are setting the detection volume properties of a sensing nose, that what are the parameters proximity sensors that we are designing. So the structure which you will going to get will be something like this. So let me do it on the software. We will double click on this, enter the 0.005. Okay, range will be 0.15, and angle which we will be adding will be 30°. Okay, now you can see that the wide angle which we were having for the proximity sensor, or we can say sensing nose, is now being reduced. Now again you have to double click on sensing nose, and then you have to click on show detection parameters, and then you have to uncheck item don't allow detection if the distance is smaller than this. Okay, so you can see that we are saying that don't allow detection if the distance is, we have having a distance in meters, so if it is less than 0.1 meter we are not allowing the detection. Go on this show detection parameters, and already you will going to see don't allow detection if the distance is smaller than this. So already it is being set. Now next step is that we have to select the sensing nose, and then you have to press the control button, and then you have to select a bubble rope. Now what we are trying to do is that we are trying to make a sensing nose as a part of a bubble rope. So what we will going to do, first we will going to select a sensing nose, we will going to press the control, and then we will going to select the bubble rope, and then we will going to make a last selected object as a parent. So you will going to see that sensing nose will going to come under the bubble rope. So I am doing this, sensing nose is already selected. Now I am pressing my control button, and then I am selecting the bubble rope. Okay, so now both of the object is being selected, and I'm going on to the edit button and making last selected object as a parent. So now you can see that sensing nose is now a child of a Bubblerob. If you are using a new version, so you can have a property like this: set parent, keep pose. Okay, so instead of make last object as a parent, you will be getting this option: set parent, keep pose. Okay. Now what next step what we have to do is that we want to create a Bubblerob wheels. Okay. For this what we have to do is that we have to go on to the file, and then we will go on to the new scene. And after new scene, what we will going to do, we will going to add a primitive cylinder, and the parameters of this cylinder will 0.08, 0.08 and 0.02. Okay, so you will get a cylinder something like this. So this will be the wheel. As we have got a motors in a car or a scooters or a bicycle, we have got a wheel. Wheel is the cylindrical in form. So we are making a cylinder form here. So we will going to go on to the file, new scene, add primitive shape cylinder, and then here we will going to add 0.08. By default y-axis will be same, and then we have to enter 0.02. Okay, make sure you are entering this. Okay, so you can see you will get a cylinder here. Now what you have to do is that again you have to make the properties of this cylinder to be a collidable, measurable and detectable. Common properties. Okay, so it is not been done, so I have to make it collidable, detectable and measurable. Now next step what we have to do, we have to make the position of that cylinder at the 0.05, 0.1 and 0.04, because we want to attach this with the our Bubblerob body. Okay, so what we have to do, we have to go on to the position tab, and then we have to enter this value 0.05, 0.1 and 0.04. I'm going on to the position tab, and here I'm entering the value 0.05 along x-axis, 0.1 and 0.04. Now next what we have to do, we have to set the cylinder absolute orientation to -90, 0 and 0. What we want, that we want to make it in a vertical direction. Okay, now we are having the cylinder in the horizontal direction, but we have seen that in a motor or a wheel we have wheel in a vertical direction. So we have to align this into a vertical direction. So what we have to do is that we have to give -90 degree 0, 0 to this particular cylinder. Okay, so the cylinder will be in this form. Click on this orientation tab, then on orientation, and then you have to give -90 and rest will be 0. Okay, now can you see it? The cylinder we have got. Now what we have to do is that we have to rename the cylinder as a left wheel. Okay, so double click on this, write the name left wheel and press enter. So let me do it. Left wheel and enter. Now what we have to do, we have, because in a Bubblerob again we will be making two wheel. Okay, like we have got any structure so that it can move easily. We cannot have one wheel, so we will going to copy and paste the left wheel, and we will going to rename it as a right wheel. Okay, so I'm going Control C, Control V, and then I will going to make it as a left wheel and it as a right wheel. Now I will going to set the properties of a right wheel, that we want that this right wheel should be have some distance far away from the our left wheel. So we will going to because we are moving in this direction, that means we are moving around the y-axis. So we will going to set the absolute y coordinate, and we will going to put it as a -0.1. Okay, so we will go on to this position, and then we will going to give -0.1 on a y coordinate system. So we will going to see that two wheels will going to be created. I'm going here and I'm here writing -0.1. Okay, Can you see? Now this two wheels are being created. Now what we will going to do, we will select the two wheels, copy them, and we will going to switch back to the scene 1 and paste the wheel. Okay, so what we have to do, we have to perform the Control C, Control V. Now you can see our wheel is been somewhat attached to this bubble rope. Okay, right now they are not attached, but it is in the alignment to it. Okay, we will going to attach it now. What we have to do, we have to attach these wheel to the bubble rope. So we will going to add a joint. The joint will going to work as a motor. Okay, so how we will going to do, we will go on to the add joint, and then we will going to add a revolt joint. Add joint, and then I'm adding a revolt joint. So now you can see that the joint which I'm getting is in the center. Okay, so we have to shift it. So we will going to select the joint, and then we will going to select the left wheel. Then we will going to go on to the position, and we will not going to enter anything. Okay, we will only click on apply to selection. Okay, so you will going to see the joint which is coming in the center of a bubble rope will going to come now onto the wheel. So what we have to do, we have to click on revolt joint, then control left wheel, and then we have to click on position and apply to selection. Okay, so now you will going to see that now we have got this revolt joint is coming in the center of the wheel. Now again what we have to do, again we have to select the joint, then control, then we have to select the left wheel, then we have to go on to this orientation tab, and then we have to click on apply to selection. So now the revolt joint which is at this degree, 90 degree, it will going to turn to the minus 90 degree and will going to come into the center of the wheel like this. So orientation tab and apply to selection. So you can see it is now in this form. Again we have to rename the joint to the left motor. Same step we have to do. Left motor, we have to give the name left motor and have to press enter. Now we have to click on the joint which we have created, and then we will go on to the show dynamic properties, and we will going to enable the motor and check item lock motor when target velocity is 0. That means motor should not move. Okay, so we will going to see that motor is enabled. We will going to enable the motor and lock motor when target velocity is 0. Okay, if you are using a new version of a CoppeliaSim, then you have to select the velocity control mode there. Okay, there are different mode available, so you have to select the velocity control mode. So in an old version you will be having this joint dynamic properties that you have to make a motor enable and lock motor when target velocity is 0. So let me go here, show dynamic property, motor enable and lock motor when target velocity is 0. Now what you have to do, whatever you have done for the left wheel, you have to repeat this step for the right wheel. Okay, so again you have to add a revolt from there, joint revolt, and you will get this revolt here. Then what you have to do, you have to select a joint, then you have to select the right wheel, and then you have to go on to the position tab and you have to click on apply selection. Okay, so you will get something like this. So let me do it here, add joint revolt. Okay, I'm selecting the revolt and right wheel and going on to this position, apply to selection. So here you can see that I have got this one. Again I will going to select the joint and then press the control, and then we'll going to select a right wheel, go on to this orientation tab and we're going to click on apply to selection. So now you will see that now my two wheels are being attached to these joints. So I will go on to this orientation tab and apply to selection. Okay, so can you see now the two wheels are being joined together with each other. We will going to rename the joint to the right motor. Okay, double click and we will going to enter the name as a right motor and we're going to press it. So I am writing here right motor, enter. Now what we have to do, again we have to do the same thing. We have to go on to the properties of this, and we will going to click on show dynamic properties, and again we have to enable the motor and check item lock motor when target velocity is 0. So you will be getting something like this. So I'm going on to this show dynamic properties, motor enable, lock motors. Okay. If you have done till here, what you can do, you can save your model. Okay, so how you will going to save the model? Go on to file, save scene. Okay, whatever the name you want to give. Let's say I'm saving it on my desktop, and I'm saying that okay, bubble test model 24. I'm saving by this name. I'm saving it. Okay, so we should practice it every time, that whenever we are building the models, we should save it so that if any time our CoppeliaSim crash it out, we should have a whatever the step we have done, it is available to us. Okay, now let me play from this. Okay, so we start the simulation from here, and now you can see that the bubble rope which we have designed, all the wheels are being fallen out. Okay, and what are the proximity sensor we have got is also gone. Okay, so we can stop this simulation. Okay, so one thing also very important is that whatever the step you are doing, you should always make sure that your simulation are being stopped. Okay, if you are running and then you are making all the changes in the bubble rope, it will not going to come into the effect. Okay, so whatever the step you are making it, make sure that you have stopped the simulation and then you are going doing the things. Okay, so what we have to do next, we want to join this thing. So what we have to do is that first we have to select the left wheel, then we have to press the control, then we have to select the left motor. Okay, and then we have to make a last selected object as a parent. So now you can see that left wheel is now the part of a left motor. First what we have to do, we have to select a left wheel, then control, left motor, add it, make last selected object as a parent. Now they are both connected to each other. Now the same we have to go for the right wheel, select the right wheel, then select the right motor and make last selected object as a parent. So right wheel, right motor, and then make last selected object as a parent. Now what we want to attach the two motor to the bubble rope. Okay, so what we have to do, we have to click on the right motor, then we have to click on the left motor. Okay, and then we have to click on the bubble rope, and then we have to make a last selected object as a parent. Now bubble rope is different body, left motor is different body, right motor is different body. They are not the part of each other. So we want that it's left motor, right motor should be the part of a bubble rope. Okay, so what we are doing, we are just selecting the left motor, we are selecting the right motor, then bubble rope, and then we are saying add it, make last selected object as a parent. Now you can see, now everything is in the bubble rope. So sensing nose, right motor, left motor are the child of a bubble rope. So bubble rope is the mother now. So again what you have to do, control S, save the model. Okay, so you can see here scene was saved, and you can see that it is also giving where the model is being saved. Okay, now what we will going to do is that we will going to try to run the model. Okay, now what you can see, now wheels are not going away, bubble ropes joint is not going away, the proximity sensor is not going away, but what is happening is that as soon as we going to run this bubble rope, okay, we play the simulation, the bubble rope body is falling down. Okay, why it is happening is that because the bubble rope body which we have designed is not having that much mass and inertia, okay, that it can hold the weight of this bubble rope. So what we have to do, we have to balance this bubble rope. So in the next video we will going to learn about how to balance this bubble rope. This is the first part of this experiment which we have done. Thank you everyone.